Technical debt, also known as tech debt, design debt, or code debt, is a term used in software development to describe the cost of future rework or refactoring resulting from choosing a limited, quick, or suboptimal solution in the short term. The metaphor was first introduced by software engineer Ward Cunningham in 1992 to explain how short-term compromises in code quality could lead to long-term consequences if not properly managed. Like financial debt, technical debt accrues interest over time, making future changes more costly or complex if not repaid through code improvement. Technical debt arises when development teams prioritize rapid delivery over code quality, architecture, or maintainability. These shortcuts might include skipping documentation, avoiding proper testing, hard-coding values, writing duplicate code, or bypassing architectural best practices. While these decisions may accelerate delivery in the short term, they often lead to decreased performance, reduced scalability, and increased effort for future changes. Technical debt can be categorized in various ways. Deliberate or intentional debt is taken on knowingly, often to meet a deadline or test a business idea quickly. It is acceptable if tracked and managed. Accidental or unintentional debt occurs due to lack of experience, poor design, or oversight. The team may be unaware of the implications at the time. Bit rot or aging debt accumulates over time as code bases grow, change, or become outdated. Even well-written code can deteriorate if it's not updated to reflect changing requirements, technologies, or dependencies. Design debt results from poor or insufficient system architecture decisions, leading to scalability and maintainability issues. Documentation debt involves inadequate or outdated documentation that makes it hard for developers to understand or modify the system. Technical debt can stem from multiple sources, including time constraints. Teams rushing to meet release deadlines may skip best practices. Changing requirements as business goals evolve, previously sound code may become outdated or misaligned. Lack of experience, junior developers may write inefficient or redundant code without realizing its long-term impact. Inadequate testing, skipping unit or integration testing leads to fragile systems. Tooling and technology drift. Dependency on outdated libraries or frameworks can cause maintenance issues over time. Poor communication, misalignment between teams, unclear requirements, or lack of documentation contributes to poor code quality. The presence of technical debt can have both short-term and long-term consequences. Decreased developer productivity, more time is spent reading, understanding, and fixing bad code. Increased defect rate, poorly structured code is harder to test and more likely to contain bugs. Slower feature delivery. Teams may struggle to add new functionality without breaking existing components. Higher maintenance costs. Extra effort is required to make even minor changes. Employee frustration and burnout, constant firefighting can demotivate developers and lead to turnover. While technical debt is metaphorical, some tools provide ways to estimate and track it quantitatively. For example, static code analysis tools scan code bases for issues like complexity, duplication, and code smells. Technical debt ratio, a metric that compares the cost to fix code issues to the total cost of rebuilding the application from scratch. Code health dashboards, used in Agile or DevOps workflows to track debt as part of technical KPIs. Managing technical debt involves balancing delivery speed with sustainable code quality. Key strategies include refactoring regularly, dedicate time in each sprint or iteration to improve existing code. Code reviews, peer reviews help catch potential issues early. Test automation, unit and integration tests improve confidence in refactoring. Documentation and standards establish and follow consistent coding practices. Backlog tracking, treat debt items as backlog tasks or bugs and prioritize them alongside features. Technical spikes, allocate time for technical exploration before implementing features. Not all technical debt is harmful. In some cases, taking on a small amount of well-understood and well-documented debt is a valid business decision. For example, a startup may intentionally defer writing comprehensive test coverage in order to validate a product idea. However, when such debt is ignored or unmanaged, it can spiral into serious technical liabilities. Technical debt is closely associated with Agile and DevOps methodologies. Agile teams are encouraged to be adaptive, but unchecked velocity can increase debt. Modern DevOps pipelines often incorporate automated testing and static analysis tools to identify and address debt early in the development lifecycle. Agile frameworks like Scrum also provide specific ceremonies, like retrospectives and sprint planning, where technical debt can be discussed and prioritized. Technical debt is an inherent part of software development, arising from the trade-offs made between speed, quality, and cost. While it can be a useful tool when consciously managed, unmanaged technical debt can lead to unstable software, frustrated developers, and higher long-term costs. Recognizing, tracking, and actively addressing technical debt is essential to maintaining a healthy, scalable, and maintainable code base.